Okay, here is section 3, solving inequalities using multiplication or division. A lot of what we do here is very similar to what we do in section 1 of chapter 2. There's one thing that's different, okay? All right, so we have this rule: if C is bigger than 0, that it keeps the inequality true. If we know that A is bigger than B and we multiply both sides by C, it's still bigger than the right-hand side. Same as if it's smaller. But where things are different is right here. If the number that we're multiplying by is smaller than 0, what you're going to notice is that it actually flips the inequality. A is greater than B. If we multiply the left and the right by a negative, now the left is smaller than the right. Okay? Let's see what's that saying. So in a positive, we have -2 is less than +3. We all agree with that. When I multiply both sides by 2, the numbers just get further away. But look what happens if they're negatives. Okay, I know that 3 is greater than 1, and then I multiply both of them by -2. 3 moves all the way down here, and 1 moves only there. So now the two of them have switched places. Okay, this is it in words and an example. Multiplying or dividing each side by an inequality by a negative number changes the meaning of the inequality. You need to reverse or flip the inequality symbol to make the inequality true. Here's an example. If we know that 3 is greater than 1, multiply both sides by a negative. -2, -2. What we get on the left is now -6 and -2. If we kept the inequality, we're saying that -6 is bigger than -2, and that's not true. So we have to flip the inequality. Okay, let's look at some. X over 3 is less than -2. We're going to get rid of the divided by 3 by multiplying it. We're multiplying by a positive, so we do nothing to the inequality. Less than, open circle, shade left. We're good. Okay? Oh, excuse me. Pardon me. C over 8 is greater than 1/4. I'll give you a minute if you want to pause it. Multiply both sides by 8. We get C is greater than 2. So I draw my number line. I know I'm close to the bottom, I'm sorry. Open circle on 2, shading to the right. Okay? So that one we multiplied by a positive. We didn't flip the inequality. Okay, now we're going to multiply by a negative. Okay. I want to get rid of this multiplied by 3/4. So I do that by multiplying by the reciprocal, -4/3. That's going to cancel, giving me a W. I flip the inequality and I get -4. Remember, if I don't flip the inequality, then I don't have a true statement. So, this one's a closed circle because it says less than or equal to, and then I'm shading to the left. Remember, we check two things. We check the number itself, so we plug that in right here, and we plug in something in the shaded region. That's -5. That also is true. Okay, so I'm going to let you look at this one. I'll rewrite it for you real quick. It looks kind of weird. Okay, pause it. We're going to both graph it and check it when you play. Okay, so that's what you get. We're multiplying both sides by -3, so we get n, flip the inequality, +3. Open circle, shading right, pick the number itself, 3. This is an open circle, so it shouldn't work. And then we pick something in the shaded region, so I picked 4, and that one does work. Okay, division. Nothing fancy with division unless C is less than 0. Notice that the inequality flips. Okay. Okay, so here I want to get the Z, so I'm going to divide both sides by 11. Now, don't be fooled. I have to divide by a negative in order to flip the inequality. Just because this is negative doesn't mean we flip. Okay. Then I draw the number line. Okay. All right. Dividing by a negative this time. Okay, so I want to divide by -9, so I'm going to divide both sides by -9. I get y, notice the inequality flipped, y is greater than or equal to -7. Close circle on -7, shading to the right. Okay. Check how it works out. We have the inequality, and then we've got 4 graphs. See which one matches up. And yeah, that's it for section 3. See ya.